I'm Sanjika Nandini, Assistant Professor, Department of Computer Science. In this video, I'm going to teach in the topic about 8086 microprocessor architecture. These are the topic covered in this PPT. What is microprocessor? 8086 microprocessor, features of 8086, microprocessor architecture, bus interface unit, functional parts of bus interface unit, execution unit, and the components in execution unit. Now see one by one in the upcoming slide. Before going to microprocessor architecture, first we know what is microprocessor and what is 8086 microprocessor. So what is microprocessor? A microprocessor is a digital device on a chip that can fetch instruction from memory and decode the instruction and execute them and give the result to the output unit. 8086 microprocessor. 8086 microprocessor is an enhanced version of 8085 microprocessor that was designed by Intel in 1976. It is a 16-bit microprocessor having 20 address line and 16 data line. It supports two mode of operations, that is maximum mode and minimum mode. If 8086 microprocessor having a multiple processor, then the system support maximum mode operation. If 8086 microprocessor having a single processor, then the system support minimum mode operation. These are the features of 8086. 8086 has an instruction queue. The instruction queue which stored 6 bytes of instruction from memory, which result in faster processing. 8086 was the first 16-bit processor having 16-bit ALU, which is arithmetic logic unit, 16-bit registers, internal data bus and external data bus, which are also result in faster processing. 8086 available in three versions based on the frequency of operation. The first one is 8086 with 5 MHz and the second one is 80862 with 8 MHz and the third one is 80861 with 10 MHz. 8086 uses two stages of pipelining, that is fetch stage and execute stage. Both are used to improve the performance of 8086 microprocessor. Fetch stage can prefetch up to 6 bytes of instruction and store them in the instruction queue. Execute stage execute these instructions. This is the microprocessor architecture. So the 8086 architecture contain two parts. One is BIU and the another one is EU. BIU, which refer bus interface unit, EU as execution unit. Bus interface unit contain three functional parts. The one is segment register, contain 4 segment and 1 pointer register. 4 segment registers are extra segment, code segment, stack segment, data segment and one instruction pointer. And the BIU contain address generation circuit which calculate the physical address of the instruction. By using the formula physical address equal to segment address into 10 plus offset address, which is referred by the symbol sigma. And next BIU contain instruction queue which hold 6 bytes of next instructions. It is also called as prefetch instruction queue. It works under first in first out manner. Next execution unit contain control system which control the microprocessor, all the microprocessor unit, and arithmetic logic unit which is used to perform all arithmetic and logical operation, and flag, the values stored in flags are depend upon the ALU. And EU contain two registers, one is general purpose register and another one is a special purpose register. In this, the first four refer general purpose register and the last four refer the special purpose register. So in upcoming slide we can see one by one in detailed. And now how the microprocessor architecture work. All the instructions are stored in memory. Here we want to fetch the instruction from memory. The first task is to be obtained is physical address. The physical address is calculated by using the segment register. Suppose, for example, the code segment contains the segment address and the instruction pointer contains the offset address, then this address are given to the address generation circuit, which calculate the physical address by using the formula physical address equal to segment address into 10 plus offset address. After calculating the physical address, it will fetch the instruction from memory. After fetching the instruction from memory, it will give to the it will pass through the C bus, which is called data bus, to the instruction queue. It store the instruction it store the instruction in the instruction queue. Based on the size of the instruction queue fills up. If the instructions in the instruction queue are ready for the execution, then it gives to the control system which resides in execution unit. Here the decode takes place. In this, the decode control system generate the opcode and inform all the microprocessor unit what operation to be performed. The control system tells the microprocessor unit and give the signal to the microprocessor unit to what operation to be performed and what data to be extract from general purpose register and special purpose register. If data are extracted from general purpose register, the data given to the arithmetic logic unit based on the instruction. The instruction may be addition, subtraction, multiplication, division, whatever. The data given to the arithmetic logic unit, and the arithmetic logic unit perform the operation and perform the operation. According to the arithmetic logic unit, the flag values are changed dynamically. In this execution unit, we can do decode and execute. At the same time, the bus interface unit does not remain idle. It continuously fetches the instruction from memory and give to the instruction queue, and the instruction queue is ready for execution whenever the time arrives. So this is how the microprocessor architecture works. And in this architecture, the fetches, decode and execute are all happen in parallel but not sequential. Now let's see the one by one components in microprocessor architecture. So 8086 has two blocks. The first one is bus interface unit and the second one is execution unit. So bus interface unit, BIU, it take the data and address transfer on the buses for the execution unit. It performs sending address, fetching instruction from memory, reading data from the port and memory, as well as writing data to the port and memory. When execution unit is busy in instruction execution, bus interface unit fetches instruction from memory and store them in the instruction queue. Execution unit and bus interface unit are connected with the internal buses. The bus interface unit contains 4 segment register and instruction pointer, an instruction queue and address generation circuit. Let's see one by one. The first one is instruction queue. BIU contains the instruction queue. It gets up to 6 bytes of next instruction and store them in the instruction queue. When execution unit execute the instruction and is ready for next instruction, then it simply read the instruction from this instruction queue, resulting in increased execution speed. The 806 microprocessors support pipelining technique. What is pipelining? Fetching the next instruction while the current instruction execute is called pipelining. Next, segment register. BIU bus interface unit has 4 segment register, that is CS, DS, SS and ES. CS code segment, DS data segment, SS tag segment and ES extra segment. It holds the address of instruction and data in memory, which are used for processor to access memory location. It also contains, that means segment register also contain one pointer register called instruction pointer. Let's see one by one register. Code segment CS. It is used for addressing the memory location in the code segment. Next, data segment. It consists of data used by the program and is accessed in the data segment in the memory by an offset address or content of the other register that hold the offset address. Stack segment. It handles memory to store data and address during execution. Next, extra segment. Extra segment is a additional data segment which is used by the string to hold the extra destination data. Instruction pointer, which is a 16-bit register. 8986 microprocessor has 16-bit registers. All the registers are 16-bit because 8086 microprocessor is a 16-bit microprocessor. So instruction pointer used to hold the address of the next instruction to be executed. Next, address generation circuit. The BIU has a physical address generation circuit. In bus interface unit, the circuit shown by sigma symbol is responsible for calculation unit, which is used to calculate the physical address of the instruction in memory. It generates 20-bit physical address using segment address and offset address. This is the formula for calculating the physical address. Physical address equal to segment address into 10 plus offset address. Next, execution unit. The execution unit fetches the instruction from queue in bus interface unit and decode the instruction and execute the instruction by using the arithmetic and logic operation in ALU. Provide address to the bus interface unit for fetching data or instruction. So these are the components of execution unit. The main components of execution unit are general purpose register, ALU, special purpose register, instruction register and instruction decoder and the flag or status register. Let's see one by one. First one is general purpose register. 4 16-bit data register or AX, BX, CX, DX. These are all general purpose register. AX, BX, CX, DX, which store intermediate value during execution, each of which has two 8-bit parts. One is high order bit and another one is low order bit. For example, AX is a 16-bit register, then it have two 8-bit part. One is AH and another one is AL. AH is a 8 high order bit register and AL is a 8 low order bit register. Same, BX is a 16-bit register. BH and BL are 8-bit registers. CX is a 16-bit register. DX is a 16-bit register. CH, CL, DH, DL are 8-bit registers. And H is a high order bit. L is a low order bit. AX register is a combination of AL and AH register. It holds operand and results during the multiplication and division operation. Also, it is called as accumulator during string operation. BX register. It is a combination of BL and BH register. It holds the memory address, that is offset address, in indirect address mode. Next, CX register is a combination of CL and CH register. It holds the count for instruction like loop, rotate, shift and string operation. DX register is a combination of DL and DH register. It is used with AX register to hold 30-bit values during multiplication and division. Next, special purpose register. This is also a 16-bit register which is also called offset register. It points to specific memory location under each segment. So let's say one by one special purpose register. The first one is stack pointer. It points the top of the stack. The stack is in the stack segment. Used during instructions like push, pop, call, return, etc. Next, base pointer. The base pointer can hold the offset address of any location in the stack segment. It is used to access a random location of the stack. The source index, which hold the offset address in data segment during string operation. Destination index hold the offset address in extra segment during string operation. Next, arithmetic and logic unit, also a 16-bit unit, perform 8 and 16-bit arithmetic and logic operation. Next, instruction register and instruction decoder. The EU fetches an opcode from the queue into the instruction register. The instruction decoder decodes the instruction and sends the information. The instruction decoder decodes the instruction and sends the information to the control circuit for execution. Flag or status register. Flag register is also called as program status word. It has 9 active flags, 6 are status flag and 3 are control flag. 6 status flags are carry, parity, auxiliary carry, 0, sign and overflow. 3 control flags are direction flag, interrupt enable flag, trap flag. So first one, carry flag. This flag is set. In addition, the most significant bit can have a carry. Then this flag is set. In subtraction, the most significant bit has borrow. Then this flag, carry flag is set. Parity flag. In lower byte of result contain even numbers of 1, then the parity flag is set. If odd numbers of 1, then the parity flag is set to 0. Auxiliary flag. This flag contain lowest nipple, that is bit 3 during addition, or borrow for the lowest nipple, bit 3 during subtraction. In this case, the auxiliary carry flag is set. Zero flag. This flag is set to 0 when the instruction, when we compare comparison performed by an instruction is 0. Sign flag. This flag is set when the result of any computation is negative. Trap flag. If this flag is set, the processor enters the single step execution mode by generating the internal interrupt after the execution of each instruction. Next, interrupt flag. The 8086 recognizes external mask interrupt. Clearing the interrupt flag disable these interrupts. Next, direction flag. This is used by string manipulation instruction. And the string is processed beginning from the lowest address to highest address, that is auto increment mode, then the flag bit is 0. If auto decrement mode, the string is processed in auto decrement mode, that is highest address towards the lowest address, then the flag bit is set to 1. Overflow flag. This flag is set if overflow occur, that is the result is more than 7 bit in case of 8 bit and also more than 15 bit in size in case of 16 bit sign operation. Then the overflow flag will be set. So these are all the components in execution unit and bus interface unit. Thank you all.